Okay, so as a reminder to everyone, this is being recorded and will be posted online. And with that, I think we can get started. Can anyone scribe? Let's kick off with that great part. Anyone feels adventurous enough to scribe? Or partly scribe? Like I can co-scribe someone if someone's...
I can try to take some high-level notes.
Okay, awesome. Thank you. Yeah. So there's a link to the minutes doc in the agenda. And for the next call, this will probably be a tricky one. If I understand correctly, next week is Thanksgiving, and therefore everyone are out. Is that a good assumption? Yeah. So the week after that, so the week of December 2nd, will we shall we go back to Thursday on that week? So December 5th? Would that be December 5th, same time, so 11 a.m. PST? Does that work for folks? Any objections? Okay, so let's go with that. December 5th for the next call at 11 a.m.
Actually, just make sure you tell Ryosuke about it.
Yeah, I will. And yeah, he couldn't make it today. So yeah, worst case, we'll...
I remember he had a conflict on Thursday, but I don't know if it's a full day conflict or what time it was. So that's why...
Yeah, I will. So yeah, I will take an action item to actually kick off a thread right now that a poll regarding that to see if we need to move times around. Okay, and with that, Scott, do you want to kick off the presentation?
Sure, sounds good.
I moved things around so that basically I'm not sure that the resource timing related issues will be super interesting for you. So start presenting, and then you can stay, but you won't have to.
Okay, cool. Thank you. Let me just join this real quick. You said approximately 20 minutes?
Yeah.
Okay, I think I have like 15 minutes of content unless I start blathering, so just stop me. But I want to make sure there's plenty of time for questions. So I might stop a little bit early to gauge where we're at. Just getting my presentation up. The talk is linked in the notes too, if you want to follow along. Okay, hi. So for those that don't remember, I'm Scott Hasley, and purpose of this is to give you all an update on the post-task API, specifically a switch in the API shape. So just a quick recap, we presented this API at the face-to-face in June. And to set a little bit of context, the API we're talking about here, I presented a couple there. This one is just for post-task, which allows us to schedule or prioritize tasks with the browser. And the old syntax is something like this: let task equals scheduler.posttask. So that's the basic context. So an update of where things are at since we last spoke in June. We worked first on implementing kind of a V0 of this task queue-based prototype that I presented, and got that out to some folks. A little bit of initial feedback just on functionality, that things are working as intended. But we've kind of pivoted to start really rethinking API shape. And some of that is in response to some tag feedback that we had. Asking, and that's linked there for folks that want to follow along, asking how we would incorporate the abort signal concept, which is in the platform, into the API. So we started thinking about this a lot, and turns out we think this is a good idea and are changing to a signal-based prototype, and that's what I'm going to talk about in detail here. That's a work in progress. The CL is under review right now in Chrome. And then the other thing we've been up to is starting to think about spec issues around priorities. How much flexibility are we going to give browser vendors? So this has been a discussion that has gone on the tag review thread. Boris from Mozilla was quite involved with this, and I think we've reached a point of understanding, but we'll see once we start drafting a spec. So I won't have time to talk about that today. There's just not enough time, but I'm happy to come back for another design call and talk more about like how we're going to spec priorities, how that should work, if that's interesting to this group. So a roadmap of where we're going. What we're going to work on next is continue to resolve any API shape and functional questions. The tag review was kind of preliminary, so they're going to be giving the explainer, which I need to update with this with a new API shape, but they're planning to give a more full review, so we'll see what comes out of that. We want to move towards an origin trial to evaluate performance, API shape, and ergonomics. And we're also starting to tackle a lot of the big concerns, the post V0 concerns, such as starvation. What do we do about controlling third-party script? These kind of big questions that we're not planning to tackle in V0, but we're starting to think about what the path forward is there. So don't have any great updates. This is a lot of brainstorming going on, but we'll definitely keep the group in the loop on that. And then hopefully soon start working on what the V0 spec will look like. So yeah, most of the time left, I want to just talk about what this API shape looks like and solicit feedback from folks, what people think of this. So again, in response to tag feedback, we started thinking about what the API shape looks like and how we might incorporate this controller signal pattern. I'll give an example of that for folks that aren't familiar with it on the next slide. But basically, we have this concept in the platform of an abort controller, an abort signal, that lets you control async work after it's been queued with the browser. And what we've discovered is two things. One, this really helps us model. It changes the way we model tasks, and it fits a really specific model that resonates with web developers that we've shared these ideas with. Also, the basic overview and API shape change is we're removing explicit task objects, replacing that with a promise. And removing explicit task queue objects for now. So what this looks like, and the next few slides are going to be kind of diffs, so you can see what the API shape look like, and then I'll talk about why I think this is a good idea, and we can have a conversation about that. So again, there's a bunch of links in here. We have a thread going on our explainer repo where we started circulating these ideas, so there's some more context there. So the new API in the base case is very simple. It's just schedule work, get a promise. So this really simplifies the base case. In the previous example, you would have a task object, and we hung the promise to represent the result off of that task. So you would have either two-step or await something.postTask.result. We also let you do this through task queues, which was even more verbose. You could get a reference to a specific task queue, post a task on that, and then read its result. So really simplifying the number of objects in the base case here, which people are happy with. Some people anyways are happy with. So onto this idea of, so this is great if we just return a promise. It's kind of in line with a lot of APIs that we have, but how do you control it? And there was a long conversation some time back about how you do this for fetch. And what they settled on in the platform was this idea that we can create a separate controller object. The controller object has a signal, and that signal can be used to observe events. So the first example at the top is how we did that with fetch. So we can create an abort controller, and the abort controller propagates cancellation, abort. You pass that to one or more fetches, and there's other APIs that take abort signals. So there's this heterogeneous group of work that can accept this signal, for example, like geolocation, things like that, which is why this question came up. Well, what about post-task tasks? So changing the API, at the bottom, you see how this would integrate in post-task. And the post-task API starts to look a lot more like existing APIs that we have. So underneath there, you can say post task foo and pass the same signal to both fetch and post task. I should mention task controller will expose a task signal, which inherits from abort signal. So you can pass these anywhere that takes an abort signal. And that's really where the power of this, I think, comes. We'll talk about that a little bit more in a minute. So again, controlling heterogeneous async work, the new approach is just share a signal. The signal, is kind of representing a specific relationship, tightly coupled tasks. And now with one go, we can say controller.abort, and this cancels the whole lot. And in the old case, we would have to, keep track of tasks, either in a post-task tasks, either in a custom task queue in user space, like an array, or a custom task queue that the platform supports. And we'd have to deal with both of them separately. So it's a little nicer here for developers to be able to just think of this conceptually as, one thing, one group of tasks. And again, controlling related tasks, before we let you control related tasks through task queues, which is in the bottom. And now, at least, I still think there might be a place for exposing task queues, and we can talk about that later. But this is how we're expressing relationships now, is by sharing a signal. So that's really the API change. Are there any questions about that part before I go on to why I think we are doing this? Okay.
Sorry, what's the controller priority? What does that mean?
Oh, sorry. So yes, I should have mentioned. So task controller inherits from abort controller. So it has, this is something we'll be adding with this API. Task controller allows you to not just abort, but also to change priorities. So instead of just propagating a abort signal to everything that holds the signal, you can propagate priority change events to everything that shares the signal. So previously, we would do this through changing the priority on a task queue, but now this is something that the controller allows you to do. And I think one of the advantages of that, which is my second point here, is that this is really forward-looking. There's signals are the way that the web platform is going to signal some sort of state change on async work. And priority being one of them, we can integrate this with other APIs. We've thought, and actually there's there's an issue open, I don't have it linked here, on the fetch repo. This was linked on the tag review. They want to do something similar for fetch. They want to have a fetch controller that lets you change priority and abort. So we're doing something similar for task. And now you can imagine if we pass this to other APIs, and other APIs detect that it's a task signal, they can act accordingly. So for example, on a fetch, if you get a priority change, we could change it so that it reprioritizes in network queues.
So first of all, this looks great at first glance. From a perspective of priority hints, for example, we were talking about adding some basically a priority parameter to the fetch, to the fetch call, but there's no way to reprioritize afterwards if things change. And this will give us that.
Yes.
So this looks great. Otherwise, if I want to create a task that will then create other async tasks with different priorities, yes, I could pass along like multiple signals to the initial task that would then propagate whatever priority it needs, like basically propagate different signals to the other tasks. Is that correct?
You could. Yeah, you could definitely do that. You can also, there's use cases for providing abort signal, but specifying a priority. So you might want a group of tasks. I have an example in another slide here, but you might have a group of tasks. Let's say it's updating some UI state. but it's done asynchronously. And it's really high priority because the user's interacting with it. But it spawns async work like log when I'm done or log this event, something that is just overall low priority. So what you can do, and we have in the design doc, is what happens if you give it a signal and a priority. Right, one of them has to win. So we think there are use cases so that you can treat the signal as an abort signal. So yes, I want this to cancel, but if you give me a specific priority, then that chain is broken. And we don't allow reprioritization. It just sticks at that priority.
Interesting. Cool.
So some other advantages here. Again, I think the thing that we just talked about in propagating this throughout other async APIs is the killer feature to me, and that was like what really swayed my opinion. Also, again, similar shape to existing async APIs, and I just think that's good for ergonomics for developers for expectations of interacting with the API. I think here with signals, you have you can easily expose state but not control. So when you're passing a task queue, you can operate on that task queue. You can change its priority. You can clear all the tasks in it, which is not necessarily what you want to do if it's sending that and passing that to code. But with signals, it's safer to pass because they're read-only. And that was part of the idea, I think, with the original abort control or abort signal proposal, is that you have a read-only component of this that you can pass around. So we get those benefits too. I think also, and unfortunately, Ryosuke is not here, and Todd, we talked at the face-to-face a lot about this, about they had concerns over priority inversion. Specifically, what we kind of settled on is, yeah, it would be great if you had a way to specify these tasks are tightly related so that you can make sure they get prioritized together. And I think Signals gives you that. So I'm hoping, and I'd like to follow up with Ryosuke, that this might alleviate some concern that they have around this. And then finally, I think shared signals are really, really good for modeling what I've been calling this task-subtask relationship, which you alluded to, which is this, I do a thing and it spawns a whole bunch of async work, and heterogeneous types of async work. I think it's really good at that. So I have just a quick example here, and there's a lot of subtlety here. I have a doc linked on the last page for folks that are interested in reading more about this. We explored this quite extensively. The way I've been thinking about this task-subtask model is that, yeah, you have this kind of meta overall thing the user's trying to do. Like, I interact with the component, I need to fetch some things, I need to update some UI, some internal state, update the UI. I think of that as a task, and all of the little things that need to happen as subtasks that help achieve that result. Whereas now you can use task queues to model that if you create a task queue just for the subtasks. Of course, you're left with having to control both of them, which is a disadvantage, but you can still do it. It's just a little bit cleaner, I think, in my opinion, this way. Now, task queues, on the other hand, I think are really good. When you want to group types of tasks, we do this in the HTML spec. Different task sources have different task queues, right? And we're allowed to prioritize between them any way we see fit. But there's nothing to say that everything in that task queue is completely related to everything else in that task queue. So for example, I'll use this again, a logging task queue. You might always want these to run at low priority, but what's to say that any two tasks in that logging task queue are tightly coupled? Now, of course, you can use both of these patterns, task queues or task queues or signals, to represent each, which makes it more complicated. I just think there's a better fit in each of these cases. And just to kind of tease out a little bit of the subtlety here that I was talking about, I think tasks and subtasks, the way I think about them is you really always want to cancel them together, because they are very tightly coupled. And most of the time, not all the time, but they can be prioritized together. If they're all, achieving that, if everything's on the critical path to the UI update, then I want to make sure they move together as far as priorities go. But not necessarily if I have some work that's part of it and related to it, like a logging task that is just strictly lower priority. Whereas task queues are the inverse. I think they're always prioritized together. Task queues represent ordering. Signals don't give you that. And I don't want to individually, if I individually change a priority, it means I need to move it to a different queue, because otherwise I break the ordering guarantees, so these are always prioritized together, and they can be canceled together. I could decide that I want to not run any logging tasks and clear the whole task queue for some reason, but they're not necessarily, that's not necessarily the case. I might want to individually cancel them. That's where I think the kind of main difference is here. So with signals, we're pushing this task subtask model more, and we talked. We talked to some developers about this, and it really did resonate with them as like, yeah, okay, this clicks. Like that's how we model like tasks. So I think it could provide ergonomic benefit too. I'll stop here for questions. I have just like some couple more slides about like where we might go with this, but it's still under consideration. So if anybody has any follow-up questions on this, love to take them now. Okay, and then quickly, so what we might do after this first version, there's been a strong demand for propagation. So how do we get that signal to all the places where it's needed so that we can specify that subtask relationship? There's been a strong developer demand so far for doing this propagation ourselves, like exposing something through the scheduler, like current task signal or something like that, or adding some sugar. The alternative is that we can pass the signal everywhere where it's needed, which for Z0 I think is totally fine until we decide whether or not this is a good idea, which some folks have raised concerns about being a potential foot gun. So I think we need to flesh that out a little bit. What it might look like is something like this. So a few options we could. So by the way, in V0 we had a current task queue that tried to accomplish the same thing, and we could replace that with current task signal. We can add an explicit inherit option as option 2 there to make it even, maybe more ergonomic, or even a separate method. So we were flirting with like scheduler.postTask or post subtask, which really like codifies this relationship. So this is, we still have some exploring to do. We still have some open questions around this. We want to hear more use cases for developers to see like, why just passing the signal isn't good enough, and what else they might need. We want to think through misuse, like is this bad? Like if we expose this and third-party libraries use it, is that what we want or is that not what we want? So we want to think through these questions a little bit more. There's still a question of whether or not we should build task queues. Like I don't think tasks and signals signals controllers are good for modeling like one relationship, but not so good if you want to model them both at the same time in the same code. So maybe there's room for doing more here. But I think it's a good start. We haven't heard a lot of pushback. It seems to match people's mental models. So assuming we don't get a lot of pushback from this group, then I think we're going to move forward with this approach and see what TAG has to say after we're done. So that's all I have there. There's a bunch of additional links for the people that are interested. We've explored these options quite a bit, and these are all public. And I just gave a talk at BlinkOn about, we focused more on the priority issue in that talk about how the priorities are spec'd and less on the API shape questions. So I have my slides linked, and the talk should be up online soon if it's not already on YouTube. So just some more context. So thank you. And any other questions in the time that we have, love to take.
Thank you. So I'm wondering if other implementers, which is basically Ben and Will on this particular call, do you have opinions on like API shape, implementability from your perspective? Things along those lines, or
I'd really defer to this, but
Yep, agreed.
What? I couldn't hear that. Sorry.
Yeah.
I agree with that. I don't have enough context to. I don't have enough context to say one way or the other what this looks like. I'm certainly not a web developer, and I think Boris, since he's been leading this, our review of it, we should defer to him on it.
Okay.
Personally, it does look better though. I
agree with that.
Yeah.
Okay. Then maybe the right thing to do is update the explainer with this material, ping the tag review, specifically Boris, and ask for feedback.
Yeah. The one thing I would like kind of a little bit is, can you tease out the differences between abort and signal propagation?
Sorry?
The one thing I would like to see kind of like explicitly specified or in the explainer is teasing out abort and signal propagation.
Okay.
That's just a request. It's, do with it what you will.
Okay.
Okay.
Yep, we'll work on that. Part of the challenge of this on the explainer is getting something fairly succinct. Like this can easily go into like really long conversations. So I'll work on trying to get this the best we can. And yeah, let me know. Happy to come back and present, anything else about like the priority work that we've been talking about with Boris. I don't know if that's of interest to this group or what the next steps with this group should be.
Yeah, lots of great work here though. Thanks.
Okay.
Is there a draft spec or?
No, there's not a draft spec yet. But trying to work towards that. Mostly we're trying to think about right now is like all the other issues that we have, like what do we do about starvation? Like what is going to block V0? And so we've been spending a lot of time on that. And that's helping us, think of in terms of spec. So I think we're getting close to where I want to start writing the draft spec. So definitely we'll loop everybody in when we get there. Okay, cool.
Okay, thank you.
All right, thanks a lot. I'm gonna bail, but thank you so much for the time. Appreciate it.
Cheers.
Cheers.
Okay. So yeah, I'm super excited about that. Seems great for priority enhancement. With that, Nicholas, do you want to start off with long tasks and buffered flag, or?
Sure. Yeah, I just wanted to give an update that on Chrome we are thinking of shipping the buffering of long tasks, meaning they will be stored from the beginning of the page up to a certain amount, so that when you call performance observer.observe with buffered equals true, then you will be able to get entries that were created before the observer was created. So the reason for this is before we thought that there might be some overhead in actually computing these long tasks, but I looked at the code and we already have all the task durations in Chrome. So I was wondering if Firefox has this as well. Like, cause I imagine you have a scheduler, so you monitor the task durations. And the other thing is, if we are okay with it, moving forward with the buffered flag, what would be a reasonable max buffer size? So to recap, we need a buffer size so that we don't just store every single performance entry forever. But at the same time, we want some decent amount so that a performance observer that is registered at a reasonable time will generally or almost always have all of the information previously. So they won't miss entries, but then we also don't want to store all the entries. So we set a buffer size limit for that. We don't have data on per frame long tasks in Chrome. So I was trying to see if we did, but I think we don't. However, we do have data on load, so time to load event. I wrote in the doc that at least for 90th percentile, it's less than 10 seconds. So if that's less than 10 seconds, that means there will be less than 200 long tasks. And that's even in the worst case, because long task is at least 50 milliseconds. So based on that rough estimate, I would propose having a maximum buffer size of 200. I don't know if anyone here has thoughts on that, or
It definitely seems reasonable. We're capturing long tasks for our RUM customers today, and we capture the total number of long tasks up to the page load beacon and maybe a little bit beyond. So I could also look to just see what our distribution of captured long tasks is.
right, with the caveat that you don't have the initial long tasks.
Potentially, yeah. We do have a way for our customers to add a snippet to the beginning of the page, and it hands off at the ones that they found to us. But we prefer not to do that. We prefer just to have a buffered flag, right? So, yeah. So I could at least find what our small view of the world shows, at least for total number.
Do you have any customers that have put it in their head?
No major big customers. It's all just our internal sites right now that have done it.
Yeah, it's probably not ideal to do that, but
yeah,
that's why we want the buffer flag.
But you never know. Like if that data would be useful.
Yeah, and I could also maybe we could take the time in when you registered, how many long tasks you have after that. And we can do the same kind of back of the envelope estimate for everything that happens before that. So if we assume everything before that is just a collection of, short long tasks, how many buffers do we need? That would give us a cap of the maximum amount.
Oh, do you mean you're asking if they have some number of time at which the long task observer registered?
Yes. So let's say the long task observer registered at 3 seconds. So we have 60, maximum of 60 plus whatever they actually seen from that point forward.
I mean, we don't need to store all of it, right? We technically.
Sure. No, I'm just saying that this will give us a good way, to take Akamai's real customer numbers.
Oh, to estimate total number. Estimate total number of long tasks.
Yes.
Right. Yeah, but yeah, I mean that's another.
Yeah, you're saying from the point where they can register a performance observer, we don't really need to buffer from that point on. So, but basically, both the time that it took to register a performance observer plus the maximum number of long tasks that you've seen at all would be both would be interesting for that estimate, I think.
Yep.
But yeah, but I agree that we don't necessarily have to register have to buffer everything. Yeah.
Okay. So any other thoughts?
Just to give you some data point for us, the P90 for the load event is 20 to 30 seconds. So it can be much higher than what you're seeing globally for the web. So I agree with Yoav's approach, but for instance, for us, we'll always register it on load. So we're dealing with a bit more extreme situation for the P90. So yeah, I mean, if you come up with numbers and share the methodology, we can just figure out if that still works for us, basically.
Yeah, so actually I'm working on getting data, real data, but that will take some time. So I was hoping if we can agree on a way to obtain an estimate based on the data we have right now. Otherwise, we can wait on the actual Chrome data, but
I would also think that in the past we've changed the buffering, like the buffer size for resource timing without any, like as long as we increase the buffer
Right.
size,
Yeah, it wouldn't be breaking if you increase.
compatible. So
I mean, technically, it could still be. Yeah, it's not ideal to change it all the time, but we could certainly change it if it is deemed to be inappropriate, like too small. And of course, it's relatively easy to know if you've very likely hit the buffer max, because you just get that number of entries on your first callback. So.
And we're not talking about any sort of set buffered size thing here, right? Like we have for resource timing. It's just register before then.
We really want to avoid having this 90 methods for setting the buffer size, clearing the buffer, and etc.
Right.
So yeah, ideally it will just have a set value which works. Okay, any other thoughts?
Other than just 200 sounds like a decent number to start with, even if we don't get a ton of really good data on it. So.
Okay, so would people be okay with speccing 200 for now and waiting for the additional data for later, and then once we get that data, we can either decide to increase it or leave it as is.
How far out is that data? I mean, from a...
It's not in the code yet, so we have to wait at least 6 weeks if we want.
Yeah. If we want data from stable.
Yeah, like, well, if we want a reasonably, yeah, I would say other channels will probably not have the same guarantees in terms of how representable the data is. So I would wait for the stable channel to produce some data.
So do you want to launch this directly or do an urgent trial for that little feature?
No, directly. We were just discussing about how much time it takes for the metric data to be deployed. It's not in the code yet, so I was just saying, like, probably 2 months, which feels like a long time, but.
Benjamin, from just like from your implementation perspective, generally for long tasks, is this something you'd be comfortable buffering, or?
I mean, I think this number sounds fine to me, and I like the simple calculation involved here. But the only thing that's concerning to me is, like, why is Jill seeing stuff that's 2 to 3 times what Google's seeing? Is that, can we get a little bit of background there?
Maybe we get more traffic from slow countries than the web in general. I don't know. Like, what second of websites did you use for this estimate of 10 seconds? Is it like top 100 websites, or where's that coming from?
It's from our user metric aggregate analysis, so it's any page load.
Any website, anywhere. Okay.
Yeah, and it's real user metrics, so it's not lab. Yeah. So I think that just saying that Wikipedia's onload is delayed a lot on the 90th. 30 seconds sounds really long.
We have Crux for Wikipedia, right? Like we have Crux data. We have Crux data for Wikipedia.
Oh yeah, but does that have onload though? I don't know.
Maybe not.
Yeah.
Generally, Chrome doesn't like onload as a metric, so I don't think we would expose that in Crux.
I think, generally speaking, it's probably because we have huge documents with lots of images. And so, yes, maybe our onload is further down than for most websites nowadays.
Yeah.
Looking at a couple of our customers that are collecting long tasks in RUM data. I'm seeing 90th percentile around 16 to 20 total long tasks, a count of long tasks being captured.
Right.
So 95th percentile around 30.
Yeah, so it seems like 200, even though it does not match Wikipedia's onload, it seems to me like it would be sufficient even for Wikipedia. I don't expect Wikipedia load to be a bunch of 50 millisecond tasks, one after the
No,
other.
yeah. I mean, from our experience, we looked at. I mean, it depends on which device you're dealing with. Like,
Right.
if you have a very slow phone, you're going to get a lot more of those. But in all the studies we've done, even in slow devices, we never see more than a dozen or 20 of those showing up in DevTools. So we don't have instrumentation in production for long tasks yet, because we were waiting for the buffer flag. but you know, that is 200 sounds very reasonable to me, and we'll be able to figure out right away if we're hitting the limit off, and we can let you know as soon as this is live. So we can iterate, it's fine. You know, we're looking forward to get some data, and then if we hit the limit often, we'll let you know.
Yeah, okay.
Sounds reasonable.
Great. So then as a next step, I'll send a PR to the. Actually, we only need to modify our new fancy registry because that one has the buffer sizes. So I'll just need to update that, which is great. And I'll ping Ryosuke to make sure he's aware. Long tasks is not implemented in Apple in Safari, but still, if he has any objections about that change, then he should just let me know on GitHub.
Yeah, I think I'll just generally, because like for the scheduling API as well, I'll just send him the video for this call and try to get him to comment on all the things.
Watch the full video.
Maybe.
That's a tall order. Anyway.
Yeah, but yeah, I agree that we need to make sure they're in the loop. Okay. So shall we move on to timing allow origin and fetch integration?
Do you want me to talk about it, or do you want to talk about it?
You'll talk and I'll scribe.
Fine. So we are trying to integrate the timing allow origin check into fetch. And so I have a PR app for it, which is mostly ready to be merged into the fetch spec, except that there was no tests, and also we need to file browser bugs for everything because we have a couple of changes. So the two changes that we have are one, instead of the same origin checks plus recently added Boolean flag for tainting, we now just check the response tainting, which is a fetch concept, which is pretty close to just checking that whether it's same origin or not. The reason we did this is to align better with coarse processing, because our objective in the end will be to have a world where if you pass coarse, then you get tau for free. In order to get that, we need to first align better with the coarse model. So that's the first change. And then the second change is we now use a method that serializes the origin. And that method will return null if the tainted origin flag is set. And the tainted origin flag basically means that there has been two origin crosses in the redirect chain. So let's say I am in A, which is my request origin. Then I request a resource in B, and then that resource redirects to C. That's already 2 origin crosses. Or it can be A, B, A. That's also 2 origin crosses. So when those 2 origin crosses occur, the tainted origin flag is set, and then you cannot use the timing allow origin header pointing to the request origin, which in this case was A. Instead, you would have to point it to star or null, I think still works.
So if null works, that seems problematic, I have to say. From I don't know. No, it's not problematic. It's just that, yeah, very few.
Null will be just
Yeah.
kind of similar to star.
Yeah.
We don't really need it because we allow multiple values.
Yeah.
But I think it was just needed on cores because they only have their header is 1 value.
Yeah.
So if you have a choice between null and star, then there will be kind of a difference in cores. Perhaps not so much for Tau, but
Yeah. Okay.
in any case, we just wanted, I guess, to make the group aware that we are trying to integrate this check into fetch, and that will result in some changes to the processing model of the check, which means that you will shortly get browser bugs. Also, Chrome also does not implement it correctly. Regarding these new changes, I guess also analytics providers can scream loudly if this change starts breaking Tau, but I hope it doesn't.
We would notice pretty quick, I would hope.
Yeah. Because like I said, now if you have multiple origin crosses, you will need star instead of being okay with the page origin, sorry, the request origin. So I'm not sure if you have any insight into whether that's common or not, but because that's pretty...
Everybody I see uses star. I don't see anybody use anything else.
Okay. So yeah, so hopefully it's not a common case and doesn't break real usage, but like I said, in the end, it will be much better to have cores imply that Tau passes. That will provide much more ample coverage for resource timing. So that was is that what you were planning to discuss with you added this, so you have. Is that what you wanted to discuss regarding the integration, or was there something else?
Yeah, I think just give everyone a heads up regarding the upcoming changes and make sure no one has strong objections, because a lot of the motivation here is alignment with cores that will hopefully enable us to treat cores as something that implies also timing allow origin. So we are not aware of any security issues that require that kind of tainting that cores implied. Like, we are aware of them in cores, we're not aware of them for timing allow origin. But it seems like the benefits of aligning are significantly larger than the 1 or 2 sites that may be impacted by this and will lose their analytics. So I just want to see if everyone agrees with that logic.
Or if they have no context.
Yeah.
That's...
I think the top level goal is certainly, it sounds great. I'm still trying to wrap my head around the non-intuitive ABA case you mentioned earlier. But I'm reading through the comment. Yeah.
Yeah, sorry, it's a little hard to explain in the conference because yeah, it is a little convoluted, I would say, and the names are not great, but
yeah, I mean, I think it's just counterintuitive when you're trying to explain it to people that the original origin is a deal breaker for the ABA case. But I think that's just me, so I'll stop talking.
No, it's definitely confusing, and I had my fair share of misunderstandings there. It's essentially 4 cores when you go from origin A to B and then back to A. Origin B now has control over the endpoint on A and can force A to do things that A wasn't intending to do unless A explicitly says, I allow this kind of cross-origin redirection through B. The reason that I think it doesn't, like for cores, it requires star because they don't have a chain of origins that they're allowing. Like for like there's no way to say access control allow origin, this chain of redirects. And plus it probably adds a lot of spec complexity to keep around that, like all the origins that went through a redirect chain as part of the request and response objects. So I think they just went with star, and I haven't heard anyone violently complaining about that. So it seems like I believe this is not a very common case. And forcing the same star restriction on tau seems like
star or null, I think. So no will work.
Yeah, but that would be a good place to start unless we understand that it breaks a very significant use case. And then we maybe, we'll see what we do about that.
Thanks. Yeah, that makes sense.